Hi guys, welcome back to my YouTube channel. My name is Dea Febriana. Assalamualaikum warahmatullahi wabarakatuh. Hi guys, welcome back to my YouTube channel. My name is Dea Febriana. I'm from the study of program chemistry, the Faculty of Science and Technology, the Islamic State of Raden Palembang. Course Physical Chemistry and lectures Jauharuddin Luthfi Al-jabbar M.Si. In video, I want to explain material about condensed phase, coefficient of thermal expansion and compressibility, and heart of fusion. Okay guys, before you're watching in video, please don't forget like and subscribe. Thank you. Come on guys.
Condensed phase. Solids and liquid are referred to collectively as condensed phase. This name emphasizes the high density of the liquid or solid as compared with the low density of gas. This difference in density is one of the most striking differences between gas and solid or liquid. The mass of air in a room of moderate size would not exceed 200 pounds. The mass of liquid required to fill the same room would be some hundreds of tons. Conversely, the volume per mole is very large for gas and very small for liquid and solid. In gas, the volume occupied by the molecule is small compared with the total volume, and the effect of the intermolecular force is very small. In the first approximation, these effects are ignored, and any gas is described by the ideal gas law, which is strictly correct only at P equals 0. This condition implies an infinite separation of the molecule. The intermolecular force would be actually 0, and the molecule volume would be completely negligible. Is it possible to find an equation of state for solid or liquid that has the same generality as the ideal gas law? On the basis of what has been said, the answer must be in the negative. The distance between molecules in liquid and solid are so small, and the effect of the intermolecular force is correspondingly so late, that the properties of the condensed phase depend on the details of the force acting between the molecules. Therefore, we must expect that the equation of state will be different for each different solid or liquid. Coefficient of thermal expansion and compressibility. The dependence of the volume of a solid or liquid on temperature at constant pressure can be expressed by the equation V equals P0 times 1 plus alpha times T, where T is the Celsius temperature. V0 is the volume of the solid or liquid at 0 level Celsius, and alpha is the coefficient of thermal expansion. The important difference between the two equation is that the value of alpha is approximately the same for all gas, while each liquid or solid has its own particular value of alpha. Any particular substance has different values of alpha in the solid and the liquid state. The value of alpha is constant over limited range of temperature. If the data are to be represented with precision over a wide range of temperature, it's necessary to use an equation which high her power of T. V equal V0 times 1 plus AT plus BT2 plus blank 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 blank, where A and B are constant. For gas and solid, alpha is always positive, while for liquid, alpha is usually positive. If the temperature increment is small, the general definition of alpha yields. We have dV divided V equal alpha times D times T. If the temperature is changed from T0 to T, corresponding to A change from 0 level Celsius to T level Celsius, then the volume changes from V0 to V. Integration assuming alpha is constant yields in V divided V0 equal alpha times T minus T0, or V equal V0 A level alpha times T minus T0. We can expand the exponential in series to obtain V equal V0 times 1 plus alpha times T minus T0. Hertz of fusion. The absorption or release of heat without any accompanying temperature change is characteristic of a change in the state of aggregation of a substance. The quantity of heat absorbed in the transformation of solid to liquid is the heat of fusion. The quality of heat absorbed in the transformation of solid to liquid to vapor is the heat of vaporization. The direct transformation of a solid to vapor is called sublimation. The quantity of heat absorbed is the heat of sublimation, which is equal to the sum of the heat of fusion and vaporization. Solid can be heated to the point where the molecules holding their bonds together break apart and form a liquid. The most common example is solid ice turning into liquid water. This process is better known as melting or heat of fusion, and result in a molecule within the substance becoming less organized. When a substance converts from a solid state to a liquid state, the change in enthalpy delta H is positive. However, if the substance is transforming from a liquid state to a solid state, the change in enthalpy delta H is negative. This process commonly known as the freezing, a result in the molecule within the substance becoming more altered. Introduction. Determining the head of fusion is fairly straightforward. When a solid undergoes melting or freezing, the temperature stays at a constant rate until the entire phase change is complete. The equation for determining the enthalpy of fusion, delta H, is listed below. Delta H equal delta H fus, where N equal number of moles and delta H fus the molar head of the substance. Sublimation. When a gas directly transformed into a solid is known as deposition. Therefore, these two processes can be summarized in the following equation. Delta H sub equal delta H fus plus delta H vav, where delta H sub is the change in head in sublimation. Delta H fus is the change in head is fusion. Delta H vav is the change in head in vaporization. Application. The head of fusion process can be seen in countless applications and evidence in the creation of many common household items. As mentioned in the opening paragraph, the most common application of the head of fusion is the melting of ice to water. The vast majority of examples where head of fusion is commonplace can be seen in the manufacturing industry. The following examples have been used for hundreds of years and are so perfect to this day. The process of coin making, glass blowing, forging metal objects, and transforming blow-molded plastic into household products all require head of fusion to become final product. The change in your wallet, the glass paste on your fireplace mantle, and the plastic soda bottle from the vending machine all went through a head of fusion manufacturing process.
Okay guys, thank you for watching until the end. I hope you can understand what I'm saying. Sorry if in my delivery there are wrong because I'm still learning. Please understand. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.